Praveen sir. Yes, Costin has come. Hello, Costin.
Oh, okay. Yes.
Welcome, welcome.
Okay. Hi.
Hi.
Okay.
So, how are you?
Okay, I'm fine. I'm ready to start. Let me know how to share my slides.
Yeah, just
I can share here. I see share
it will
screen.
take few
Let's
minutes.
try.
We have to have some formal process.
Okay.
Okay.
So,
Sir, can I start?
yes.
Yeah, okay.
Thank you.
So good afternoon, all of you. I, Dr. Praveen, thanks to 5th IEEE International Conference, ACRE 2020, to provide the opportunity to introduce Dr. Costin Padika, who is professor in Department of Computer Science and Information Technology, University of Craiova, Dolj, Romania. Professor Costin Badika obtained PhD degree in automatic control. He is teaching at the University of Craiova since 1990. And since 2006, his position is the professor of computer science in the same university. Since 2012, he is also director of the doctoral school Konstantin Belia at the Faculty of Automation, Computers and Electronics at University of Craiova. Professor Costin was postdoctoral researcher at the Department of Computer Science in King's College, London, UK in 2001 and 2002 also. The research interests of Professor Costin are at the interaction of artificial intelligence, software engineering, and distributed multi-agent systems. Professor Costin published more than 200 research papers in journals and conference proceedings. More than 200 of his papers are indexed in Scopus, and more than 150 of his papers are indexed in World of Science. He obtained more than 1,000 citations, thus providing a H index of 21 according to Google Scholar and 14 according to Scopus. We all are very much excited to listen you, sir. Now, before handing over the charge of this plenary session on topic, synergies of artificial intelligence, a multi-agent system, and software engineering research by Professor Dr. Costin, I request our director, sir, to present e-momento. Sir, please.
Okay, so thank you very much for the introduction.
Just a minute.
So
yeah,
I will try to share my slides.
Just in a minute. Yeah, I welcome with this e-memento to you to this conference, and thanks, many thanks for accepting our invitation to deliver this plenary talk in 5th IEEE International Conference, ICRE 2020. Thank you.
Thank you very much.
Sir, I'm handing over the charge to you, sir.
Okay, so I can start.
Yeah.
Yes, now you can
Thank you very much for the introduction, very nice introduction. I'm really honored to be here with you. And it's a great pleasure for me to be able to share my ideas about this topic. Okay, I will start, yes. Okay.
There is green share screen.
Okay.
And then go to your presentation. Yes, it has come.
It's okay, isn't it?
Yeah, it's visible.
Okay, so now it's full screen. Should be full screen now.
Yes.
Okay, thank you very much for this very kind introduction and very kind invitation. I'm really honored to be with you, to share with you my ideas and my results in these topics of computer science. Today, I will talk with you about some of our results. I will go through some of our small projects in our group, and I put this under the umbrella of AI, multi-agent systems and software engineering, because we are applying and producing results in these areas. So we are also interested about synergetics between these topics. And first of all, I would like to introduce my location, because probably you don't know about where I'm coming from, because we are not coming from a major European city. We are here located in Romania. It's South East Europe. And this little yellow arrow is pointing to my dear city, Craiova. I'm now here in Craiova. And we are in Southeastern Europe. 2 days ago, I had a paper in your conference, and we co-authored the paper with colleague from Serbia. Look, Serbia is here, is nearby. And also with our friends and colleagues and collaborators, researchers from Poland, who is here. So we are all of them a part of East Europe. East Europe. So now this is just to before starting to give you some ideas about our university. This is the rectorate, the central building of the university is in the city center of Craiova. So our university is like from, let's say, less than 100 years. It's a new university. It was created together with a modern Romania. And this is our main building. We have several buildings. We are a city-based campus. This is the district hall of Craiova. It's city center. It's nearby the university. And this is a picture that was taken during the summer, but looks how it looks during the winter. It's the same location. Sometimes we have very heavy winters. And this is the same picture from the city center district hall. I take it myself, I think it was 2 years ago. And this is our art museum in Craiova. It looks like a palace. Actually, the building is inspired by a French palace. So it's really built after that type of palace. This is a city hall. The mayor of Craiova is here, mayor of Craiova. This is a city hall, again in the city center of Craiova. And also we have very nice green area in Craiova. We have many parks. This is called English Park. It's a type of small square in the city center. And in the back, you can see the back of the district hall. The building that I have shown to you on previous slides, but it's from the opposite direction, from the back. And also we have another very beautiful park. Some people, Romanians, say it's the best park in Romania, actually. And this is called Romanescu Park. And it's especially very beautiful during autumn, when the color of everything is changing. Remembering us that there is no eternal summer, at some point we have to start moving to autumn and later on to winter. Because we are in a continental area. Even if we are southern part of Europe, we experience, let's say, combination of sub-Mediterranean with continental climate. So, if you want to find more about our dear city and university, you have this link. Okay, so let's go to the main topic for today. So I'm going to talk about synergies between multi-agent systems, software engineer, and artificial intelligence. And we all know they are very important topics in the area of computer science. Actually, what we have in Craiova, we have a very small group. It's made up of some colleagues and PhD students, where we study these, let's say, systems, which we call intelligent and distributed systems. And in this type of systems, we look at applications of distributed multi-agent systems, software engineering, and AI, artificial intelligence. And it's a lot of discussion about this. I could take, let's say, a very general overview, but rather than taking a very general overview, I would like to go through some of our achievements, the type of problems that we approach, methods that we use, some results that we obtained, published in different venues, to give you just an idea of what are our interests and our experiences. And in our group here, we have this IDS research group. And I think it doesn't work, the link, unfortunately, because now we are in the university in the process of changing some of the buildings, refurbishing, modernizing, moving from one place to another place. And we take, if we can, so advantage, because actually there are no advantages of this very bad period related to epidemics, COVID, and which is locked down everywhere. But there is some work taking advantage that there is no other activity in the university, and they modernize and they move servers, and that's why the link does not work. So nevertheless, what we are interested here, interested in combining intelligent computing and distributed computing, using ideas from what I said before, multi-agent systems, artificial intelligence, and software engineering. And this is very broad area, but now I'm going to give you some methods that we have experience with and that we use in our research. We apply agent-oriented programming and agent-oriented software engineering. We are interested in knowledge representation and reasoning, and formal methods. These are more like on the classical side of AI, because nowadays we are experiencing, if you can say so, a sort of paradigm shift in AI. Because I was working in AI for many years. I started to teach in this AI subject in '94. So it's like more than 30 years ago. And things change a lot in AI. But we were doing research in AI not only now, but we did it in the past. And these topics related more to symbolic processing, knowledge representation, formal methods, let's say, are more related to the traditional AI. Very different from what is known today about application of machine learning and deep learning. I will come maybe at some point back to this aspect, which I think is very important. We do also complex networks, analytics, computational optimization. We are interested in game theory, automatic negotiation, and natural language processing. And as application areas, we look in various possibilities. At some point, we were interested in e-business, e-commerce. We have some work in this area, also with our colleagues from Poland in e-commerce agent-based systems. Also, we have some interest from past years, but also from recent years in web information extraction, the service negotiation for disaster management, reasoning combined with web services, distributed storm intelligence, logistics, game theory, modeling and simulation. You see a lot of things. And I think the best way to go through all of them is to give you just some pitch from each type of project, to have some idea about methods, the type of problems, results that we do in these areas. So first of all, formal representations. Formal representations, if I want to put them in context, are at the border of AI, classic AI, and software engineering. Software engineering is using models of software systems. And AI is using, at least classic AI, rule-based systems, ontologies, logics, and so on. So you see, they are interrelated, these topics. And here we have some results on modeling business processes, either using methods from formal representations from software engineering, also from AI. And we have some publications just to give you some ideas what kind of things we are approaching. We study this type of models of business processes. They are, maybe you are familiar with BPMN, Business Process Modeling Notation. This is a modern standard, but this work was done before BPMN was produced as a standard. And we are using here a formalism which was developed in UK, United Kingdom. The formalism is called role activity diagrams. It looks like BPMN, also it looks a bit like UML activity diagrams. But we are interested to understand these models and to capture them precisely in mathematical form. And for that, using algebraic specifications, process algebras, we analyze these type of models to produce state spaces, and then we can apply logic to check, to validate using model checking this type of models. For example, you could write things like each project described by this model approved must be eventually completed and debriefed. Or each project cannot be completed and debriefed without being approved by a design quality check. You can precisely state this type of statements using temporal logic. And then you can check those formulas using model checking tools. Then we thought, okay, we have these nice models. How do we implement in knowledge-based organizations? How can we capture this type of models as reusable knowledge bases, which is also a concern of both software engineering and AI, because they are models reusable from software engineering point of view, and they are knowledge bases for reasoning from the point of view of AI. And this is also a possibility of endowing this, or encapsulating these knowledge bases into agents that we call business agents. And this way you have like a knowledge-based organization composed of agents encapsulating knowledge and interacting by means of message exchange. And this is an architecture that we proposed. It's called KB squared A squared, knowledge-based business agents and architecture. And this is how it works. This was implemented using AgentSpeak and JSON, agent-oriented programming. And this is how it works if you want to model it using the JSON agent-oriented programming language in the integrated development environment of JSON. Now, I'm moving to the next topic. We are interested into web information extraction. You know, we are not now talking about big data, but this topic of understanding the information from the web, not only by humans, but also by machines, is not a new problem. It was studied 20 years ago. And the term was web information extraction. And the data was not produced as it is produced today, because the main intention of the web was to make the information readable, understandable, and usable by humans, not by machines. And a lot of research has been done in how to transform, to package, and to present this information in a digital format that is suitable for machine processing. And nowadays, maybe with the Internet of Things and with the new advancements in the cloud and edge, maybe this problem looks a bit trivial. But look, 20 years ago, it was not like this. So we had these projects about how to extract such information and put it in a structured format from the web. And this was done in the context of a national product. And we have some technologies that we developed. So this is how it looks, the information on the website. It's like an HTML web page. And this is HTML. And this HTML contains a lot of redundant, especially if it is produced by professional editors. It is not written manually by humans. It contains a lot of extra node information, which is not, let's say, real information. It's only for presentation. We transform it into some internal format, the DOM, Document Object Model, and then we learn how to extract useful information like this using machine learning. So we have been using machine learning 20 years ago, when machine learning was not so popular in AI. And we have used inductive logic programming, which again, nowadays, maybe you are not familiar with it. everyone talks about neural networks and deep learning, but there is a lot of there are a lot of other methods developed for machine learning, and one of them is inductive logic programming. The main idea of inductive logic programming is it produces rules, logic rules, exactly logic rules. So these rules can be implemented using logic engines, or can be mapped to other web information processing frameworks like XML process. This is what we did. And also, we continued this trend of being interested in analyzing information from the web. And now, from another perspective, let's say a bit more modern, we were interested in smart tourism and sentiment analysis. And also, we have some recent work. It's related to readability analysis to understand basically what are people writing in their reviews about different topics, in particular in this work about entities which are specific to tourism. And this kind of application could be useful in the context of smart tourism. How to be smart, how to understand, how to use such information that you read from the reviews, how to learn about the people who are writing and then the people who are supposed to read your reviews. How can you leverage on extracting sentiment, opinions, and other information about the profile of your clients, of your customers. And we have applied this for both for Romanian language. We have used natural language processing in our native language, but we also have some work where we have applied it for English. Basically, we have a framework in which we extract information from the websites using crawlers. We store this information in various formats, from relational databases, graph databases, and you can use for each of the tools different type of query languages, like Cypher, for example, which is a query language for Neo4j, or SQL, which is for relational databases. Or you can simply convert your data into, let's say, specialized formats which are used by tools for analyzing complex networks, like JFI, for example, or if you want now very popular in the world of Python is networkings. And this is what you can do when you pre-process and prepare your data. And then you can do some sort of sentiment analysis. We did sentiment analysis, and we have another work just mentioning it here for readability analysis. And first of all, we have to conceptualize the information to know what kind of information do we have. How is this information conceptualized, represented? What is the, let's say, top-level schema of this information? And we conceptualize for sentiment analysis as having entities, which are the target of our analysis, facets. What can you say about various things about your entities, like, for example, hotels, or resorts, or I don't know, regions, or beach, for example, or I don't know, landscape, facets. What can you say about weather, for example, or environment, or landscape, and then the sentiment. You describe the sentiment in several, let's say, classes, at least positive, negative, and neutral. And again, we have a framework for this sentiment analysis. This was a paper that we did for our native Romanian language. And we have used a semi-supervised method. That is, it is not entirely supervised. I mean, we don't tag and then label and use supervised learning, but it's not entirely unsupervised, because we base also on some lexicons of words and valence shifters, which are other words which change the balance of other nouns, for example, like not, or they are called contextual valence shifters. So we use this type of lexicons, which are a sort of supervised information, but not entirely supervised. And then we do some dependency parsing. And then based on what we get, we apply our sentiment analysis algorithm. And also we do an analysis of the type of information that we extract, histograms from that information. And finally, we evaluate. We evaluate our work. And this is where we combine results from machine learning and information retrieval to do this evaluation. You know, you evaluate based on very precise quantitative measures like precision, recall. And what is also interesting here, we did an evaluation which is, let's say, more global. That is, we evaluate an entire entity like a resort, for example, or we can look at specific facets. We can do both. The services, landscape, kitchen, entertainment, we can evaluate all of them. And we obtain some results which are, let's say, okay, not the best, but okay. And also we do an analysis of that information, which is extracted from websites, describing so-called um, um, content sharing networks, like forums or this type of websites where the user can interact with other users by exchanging information, commenting, submitting inquiries, getting responses, commenting responses, and so on. So this is also very good to analyze interaction between users. And this is a type of problem that you approach from the point of view of complex networks. So what we did, we built a complex network from data that we extracted from some such websites. It's very interesting. And then you can use complex network packages to do some analysis. For example, you can evaluate measures like PageRank for each node to see importance of a certain user in your community of users. And then you can observe, if you want, dynamics of the network. You can see how is this network growing in time. This is also very interesting to see. Okay, so also I promised to say a few things also about software engineering, and we are also interested in this aspect. You cannot do research in even in AI if you do not spend a bit of time into software engineering and programming, because this is what we have to do. And in particular, we were attracted by this field of multi-agent systems, which for me is like, again, a sort of cross-border between modeling, software engineering, and also distributed systems. Yes, because multi-agent systems are somehow possibly described also as sort of lightweight distributed systems. You can see them also from this perspective, not only like an instrument for AI or for modeling and simulation. And we had a project, a national project, where we were interested in service-oriented multi-agent systems, and we produced some software and also some models and results, which were published. We have implemented an agent-based auction system as a distributed system, in which we look for, let's say, balancing the work of the server and distributing this work among a hierarchical structure of agents. We have in this model, we have proxy agents, and also we have participant agents, and also we have an auction manager. And then we measure the performance of our system in terms of throughput and latency. This is also very important in this type of systems. For example, when you are in an auction, how fast you can bid. This is extremely important, especially when the time is very short and when the load is very high. A lot of people submit bids. It's very important to have a very performant server for this type of applications. And also we did some work in trust and reputation. I do not have a slide about it. Okay, but also, you know, multi-agent systems have so many applications. One project that we had in the past was about disaster management. It was a European project, FP7 project. And in this project, we were interested about developing a system that can dynamically build workflows for response and mitigations of disasters. Disasters are emergent processes. I mean, you cannot, let's say, formalize precisely what do you need in order to deal with some disaster, because it is unexpected and you don't know how it will develop. Sometimes even you don't have enough information about what happened. And I'm talking here about scenarios. For example, we had some scenarios about areas where there is a mixture of industry and people, like ports. One of the scenarios was targeting the port from Rotterdam, which is the largest port in Europe. And this is a large port. There is also a very important industrial area. And where there is an industrial area, there are also people living around because they work in that area. It's normal. And also, because it is a port, a lot of things are happening in the port, transporting. And one of the, let's say, dangerous things which are transported are chemicals. And also there are plants for let's say, processing those chemicals, dangerous chemicals. So there is always a high risk for disasters. And for that type of disasters, of course, you have to be prepared, but you don't have exact workflow how to respond and mitigate. And the problem was how to use multi-agent systems and service-oriented computing in order to build ad hoc workflows on the fly to respond in the best way and mitigate the effect of the disaster. Doing all the stages, first situation awareness, and then everything. So basically, we have a framework which is able to build on the fly a sort of, it's a sort of service composition. And you have a lot of, let's say, services and experts and in the system. And then based on the problem that you observe, you try to combine all of them into a sort of workflow. And this is an example of the workflow showing exchanges of the information that happens within this workflow. And you have several modules. You have also people which are wrapped as agents, people with tools like factory representatives, chemical advisors, health experts. Also, sometimes you have to do measurements because you don't know the source. Sometimes you don't know the source. You maybe have some clue that there is something happening, but you don't know exactly the source. So you have to find out the source, and then you have to monitor what is happening and to predict if there is, for example, a chemical spill. It can be very dangerous, but not immediately. Maybe as the time is advancing. You have also specialized components like gas detection, which are methods using other techniques like machine learning, for example, to detect what's happening. And then you have negotiation and involvement of experts. And also about, for example, if you have to deal with chemical spills, at some point you may need to be prepared to bring into your workflow transportation providers with suitable container to take the chemical and transport it into a safe place. And for that, you have to do very fast sort of finding of resources. And this is done in our system by means of collaboration, which is implemented using negotiation. Okay. Now we are. This is was one of the projects, but we are also interested in others. We were interested, and we are still interested in agent-oriented programming. This was also one of the papers here in the conference. It was dedicated to modeling and simulation. In this work I'm now talking about right now, it's about application of belief, desire, intention agents. And this is a type of model which was very influential in the field of agent-oriented programming. Based on this model, there are developed programming languages. One famous such language is AgentSpeak. And we have used this AgentSpeak to develop several projects for simulation of dynamic systems, for reinforcement learning. This was work done with our internal student we had 3 years ago, and this year no, because of COVID. But we used to have in our group some students coming from France, from Limoges, and this was a paper developed with this Samuel Felton from Limoges, and we developed a system using JSON for reinforcement learning. And what was special about this, we have used agent-oriented programming because very often reinforcement learning is seen and implemented outside the world of agents. Although reinforcement learning is about how to endow agents with learning facilities, about strategies. This is what is reinforcement learning. Usually, this type of experiments and programs, for various reasons, are done outside the agent world. And for us, was a challenge to see how can we endow BDI agents with reinforcement learning capabilities. And not just for a simple experiment, but also we want to build a sort of demonstrator. And we integrated our system, which actually has, you see JSON here, two types of agents, one of a simple temporal difference learning agent, and another one combining Q-learning and SARSA, which are for reinforcement learning and in JSON, but then everything was packed into a bigger system implemented in Java partly and partly in C#. So this was an interesting project because it invoked AI, agent programming, very different from, let's say, Java programming and C#. Was an interesting experiment. Also, we are interested in simulation of games in the sense of game theory. And this is a small project also done with, we started and then it was continued by two students from Limoges to model and simulate patrolling games. Patrolling games are a sort of audit or security games. And they have applications in fighting, for example, poaching or fare evasion, when you want to travel without ticket. And they are security games. You have an agent which is, let's say, guardian, and you have a robber, and then you have to model the strategy of the guardian to defend some targets and taking into account some information obtained by observing the behavior of the robbers. So this is a sort of stochastic game because you don't have precise information about the robber. So it's a stochastic game, and the problem is how to define strategies for guardian. And usually there is theory about this, and also there is a work to do simulation. I mean, you can develop strategies and then you can simulate strategies using agent programming. And this is an example of simulating and computing utility of agents for different strategies. There are here 3 strategies. Obviously, the blue strategy is the best because it has a higher utility. And this was done using JSON. And there is also the prototype implemented by the students from France, also combining JSON. Again, interesting, but unfortunately, we don't have a paper about this. It combines JSON with PHP. So the main application web is developed in PHP, and inside it has JSON. Okay, also we are interested in reasoning. Reasoning is, let's say, part of classical AI. And this was done as part of a project with our colleagues from Thessaloniki, from Greece, we had a bilateral project, and they are experts in various types of reasonings. And a reasoning engine, I mean, there are so many. In particular, in this project, we have used defeasible reasoning, which is a sort of reasoning inspired by default logic, but which is a sort of non-monotonic logic, but made it and packaged it to be, let's say, efficient from the computational point of view. And we have implemented a system, a software prototype for brokering apartment rentals using agent-based defeasible reasoning. And this was a bit challenging because on one hand you have to use reasoning engines, and on the other hand you have to integrate everything into web. And this is not always easy. And we had a framework like this. We have clients, web servers, and we were using Jade as a multi-agent platform. And as part of Jade, we have used Emerald framework, which relies on Jade. And this Emerald is provided by our colleagues from Thessaloniki. And here you have reasoners. So you have agents incorporating different reasoning engines. And what was interesting here, your service can employ different types of reasonings to solve the problem based on user queries. The user provides some queries, some information, what I want, what I need, and then your server contains reasoning, knowledge, and then combines all of them to find an appropriate solution for you. This was the idea of this project. Also, what we also did, again, combining distributed computing, software engineering, and a sort of AI, distributed swarm intelligence. One of my PhD students, we worked and developed an architecture, distributed architecture for swarm algorithms. We have tested it for ant colony and for bee colony. It can be extended, of course, to other swarm approaches, like particle swarm, for example. And we have some papers based on that. The idea is as follows. You have, maybe you are familiar with ant colonies, okay? Ant colonies are about ants who are moving around in some environment in such a way that they can solve some optimization problem. Somehow they move, and then based on this pheromone property, they become attracted somehow by the solution to the problem. And our idea, okay, and very often this was solved in the literature as a distributed model because ants are distributed. But if you look, most of the experiments are not at all distributed. And we thought, okay, but let's try to do this distributed. I mean, okay, it is metaphorically distributed, but let's do it really distributed, okay? Because it can be useful. And we saw a possibility for this because we say, okay, what do we have in an ant system? You have an environment which depends on the problem that you want to solve. For example, if you solve a traveling salesman problem, which is a graph, your environment is a graph. And then ants are simple objects, like a sort of mobile agents, but really they are not smart. They are simply objects which move around in this distributed network. Let's do this. And we implemented this. And we were interested about the technical properties of such a system because mathematically ant colonies have been proved to have some mathematical properties already. So you don't have to check this. But it was interesting to check technical properties because really you have the distributed systems with a lot of message exchanges because this is how we model our ants. For example, ants are moving around in our map of a city, for example, and you have several nodes grouped on various different machines. Everything is distributed, and ants move around. How do you move them? We move them via message passing. And one of the problems in this architecture was on how to minimize message exchanges. How to make this architecture exchange fewer messages, because exchanging messages is time consuming in such an architecture. You have, let's say, a very fast machine, but then exchanging messages over the network is very slow compared with the speed of the machine. We had also a paper about how to try to optimize this using what is called a sort of graph partitioning. You can figure out a model on how to optimize this using graph partitioning, how to map parts of your environment onto different machines in order to minimize interaction between machines. It's an optimization problem. Another work where we developed a new concept is collective profitability. Here we were attracted by some topic that we were, let's say, interested in at some point, which is collective intelligence. And we were interested in this, and then based on this metaphor of collectives, we thought about applying it in the business context, in particular intermediation networks and supply chains. And no, everyone knows what is a supply chain, okay? And also an intermediation network, when you sell or you buy something and you go through a set of intermediaries or through a chain of suppliers, for example. And such systems define a sort of society of business entities. You have more entities which are in the same more or less problem, working together. And you have, in such a system, you have the following situation. Everyone needs profit in your network, because otherwise, if they don't have profit, they will leave the network. Everyone needs wants to have profit, obviously. And overall, your system has to be profitable. But you know, if you think only globally, like make the whole supply chain or intermediation network profitable, you might fail in making everyone happy. So our problem here was how to make the overall system profitable, but on the same time make each of the participants happy in this network. And for that, we produced this concept of collective profitability. And what we call, what is the result of this was what we call semi-competitive intermediation network. It is semi-competitive because on one hand, if everyone needs a profit, we are in some sort of competition. But on the other hand, we have to collaborate to make the whole business profitable. So we have to collaborate. So we are in some sort of competition collaboration scenario. That is why we called it the semi-competitive intermediation networks. And we have a mathematical model for this. It is based on some sort of graph optimization. And it's not easy to explain this picture here. You have sellers, 1, 2 are sellers. You have buyers, 5, 7, 8. So in this type of network, you see arrows are flowing from sellers to buyers. So you are a sort of intermediation graph, because you sell, but you don't sell directly. You go through a set of intermediaries. And here, what you have indicated by sets are groups of products or services. You have, you sell 1 and 2. 1, okay, you have 2 sellers, seller 1 and seller 2. This one is selling products or services 1, 2, and 3, 4. And how? It sells product 2 using intermediary 3 and product 1 using intermediary 4. This one gathers product 1 and 4 from sellers 1 and 2, and then bundle them together and sells them to 6, which also buys 2 from 3, and it has 1 to 4, it sells 1 to 7, and 2, 4 to 8. Okay, so it's quite complex, this flow. So it's like a flow. It's like a network flow problem, maybe this type of problem. And we model utilities for everyone using a simple buy-sell mechanism for each transaction. We model utility for each transaction, and then we model utility for each participant. And also we model the overall utility using Nash social welfare. Nash social welfare, it's a function, mathematical function, which is product of utilities. Or if you go to logarithm space, it is a summation of logarithms. And this is describing the overall social welfare of your community. And then you define utilities for each participant using such a vector formula. And then you have to describe the structure of your network. This is the so-called incidence matrix of your graph, not adjacency, incidence. It relates arcs with nodes. This type of, if you are familiar with electric circuits, incident matrix is a lot used in computational methods in electrical circuits. And we formulate this model, and then we formulate the problem of optimizing this social welfare as a convex optimization problem with constraints. And this can be solved using convex optimization packages. And what is nice for this paper, we got in 2016 in Halkidiki, Greece, the best paper award at Computational Collective Intelligence conference. We were very happy about this. Also, we are interested in other applications. For example, we have some small projects started related to freight transportation brokering. The problem is as follows. You want to transport something, and there are also transporters, transport resources. And in brokering, such situation is like, how do you match customers that need to transport their stuff with transportation providers, which have resources to transport, like vehicles, I don't know, what is needed to do the transport. And we formulated this problem as constraint satisfaction problem, because we also wanted to optimize the route. For example, this can be used, our model can be used in different scenarios. It can be used, for example, in a real market situation where you have transportation providers different than customers. They are not part of the same, they are different, of course, but they are not part of the same business. Or you can use this model for the case, for example, when you have a large company and you want to optimize your transportation flow. So you have resources for transport, for logistics, and you want to optimize the use of these resources. And for that, we have used multi-agent systems and computational optimization, but in this particular case, using constraint programming. We have used constraint programming, Eclipse. This is another tool, and was interesting to combine agents with Eclipse, because Eclipse is a tool for constraint satisfaction, but it's not agent-based. What is also interesting here, we did, one of my PhD students had this very interesting idea how to put this problem in the context of negotiation, but socially inspired negotiation, for the situation when you want to model this type of activity as a society of agents, of transporters and customers. And we have used some measures inspired by computational social networks, like PageRank, for example, or betweenness metric, to model things like competitiveness advantage. And we use these measures in, let's say, adapting the strategies of the agents during the negotiation of these transportation services. And this was done in the context of social networks. So using the problem of freight brokering, let's say we put it in the context of social networks, and applied these metrics from social networks to see how this socially inspired negotiation can, let's say, influence what is happening in this type of systems. And finally, I mean, another project, it's a bit more theoretical. It's also in the area of business processes, but it's related to optimization. We are interested in optimization of business processes using structured representations. And basically, these ideas of this work combine two worlds. One world is the world of scheduling. Everyone knows scheduling. You have tasks, and you have resources, and you have to do scheduling. Okay, and you produce schedules, a schedule for a specific problem. But schedules are not reusable. Schedules are very fragile. If something is happening in your system, let's say tasks change somehow, durations, the schedule can fail. And one approach for, let's say, producing more robust schedules is to use structured schedules, which were inspired by the area of business processes. In business processes, people are interested in modeling business processes using structured methods. And how these structured methods, okay, produce structured representations. And the idea was, how can we apply these methods to produce structured and more robust schedules? Not so efficient, because you add some extra constraints, eliminating some of the schedules, which can be better, but still you produce more robust schedules. This is the idea. And this is a complex problem. And we are also still working on this problem. And we have experiments, but also we are developing also some theoretical work. Because for the moment, for example, we suspect this is an NP-hard problem, but we don't have a formal proof for this. And this is what we are trying to do currently. But we have very good reasons to believe it is an NP-hard problem. So we tried different approaches to solve this problem using heuristic algorithms and constraint algorithms we have in our paper. Okay, so before concluding, I could speak more because I have more things to say, but I think it's time to stop. I like to thank to all my collaborators. I have so many collaborators. I think it's very important in research to interact, to exchange ideas, to have collaborators, to bring new ideas from other groups into your work, and also to try to export your ideas in other places, because this is what science is about, to not only develop, but also spread knowledge. And that's why I want to thank to all my collaborators. And also thank you very much for giving me the opportunity to be here with you. It is real a pleasure, and I will be happy to answer to your questions, to your comments. Thank you very much.
Thank you, sir. Thank you, sir. Thank you very much. I request all my participants to put any questions to Dr. Costin. Is there any questions? Yeah. So can you please unshare your PPT?
Okay. Okay.
Just a minute.
Let me see if I can. I don't know if I can. Oops. Let me see. Maybe you can stop share from here. Okay.
Yeah.
It's simple.
Just give me.
I'm using Google Meet for teaching.
We are also using the similar kind.
Yeah.
Now we are using Microsoft Teams, we are using Zoom, we are using Google Meet, all three at different times.
Yeah, okay. And faculty, they are using WebEx. When we have faculty meetings, they use WebEx because with WebEx we can vote. We can vote. There are situations when we have to vote. And voting is very important.
Yes.
I will be happy to answer to your comments, to listen to your comments or
So, participants have given any question?
No, sir. There is no question from participant side.
So, you can request them once if there is any query.
Participants, if you are having any question, please put in the question and answer box. Even panelists can also ask any question. The topic delivered by Dr. Karsten was very nice. It was related to swarm intelligence. So till now, as if there is no question, sir, can I proceed for the next program?
Yes.
Yeah, thank you, sir. So thank you all the participants. I am happy to have an opportunity to propose vote of thanks in this 5th IEEE conference ACRE 2020. My first thanks goes to Dr. Kostin Badika, who is professor in Department of Computer Science and Information Technology, University of Craiova, Dolj, Romania. We all are keenly listening your topic on synergies of artificial intelligence, multi-agent systems, and software engineering research. Your thoughts specifically in swarm intelligence and ant colony algorithm are definitely useful to all our participants and young researchers who participated in this 5th IEEE International Conference, ACRE 2020. I'm thankful to our director, Professor Dr. Mahesh Bundele sir, who is backbone and driving force to all of us in Poornima College of Engineering. My thanks also goes to architecture Rahul Singhi sir, who is the director of Poornima family to provide all necessary facilities. Thanks to IEEE Delhi section for providing technical and financial support. Thanks to all authors of papers who are presenting their research in this 5th IEEE conference ACRE 2020. Finally, my thanks goes to all participants, lovely participants. Thank you all those whose names are not taken by me, but propose their support in this conference. Thank you all once again.
No,
Lastly, I requesting to all the participants and our panelists to turn on their camera for the common photograph of this event. Dr. Payal, madam?
Yes, sir.
Yeah, please, madam.
Yeah, sure, sir. Sure. Yeah. All of you are ready, suppose? Should I take your photograph? Yeah.
To smile.
Smile.
Everyone will be happy.
Yeah, thank you, sir. Thank you, all of you.
You have to take all the screens, different screens would be there.
Okay, sir. Okay.
You are forgetting to take, you are taking only panelists.
Okay, sir. Just
participants should also be there, no?
Yeah. Shivraj, sir?
You can change the screen and see the participants, sir?
Yes, madam.
Yes, sir.
Yes,
sir. How can we see all the participants on a single screen?
Yeah, be very nice to see all of them. Yeah.
Okay. Okay, madam.
Yeah, done, sir. Done. Yeah, thank you, sir. Thank you.
So, and you announce all of them to come by 3:45.
Yes.
We'll start the program at 4 sharp.
Yes. This is a common announcement for all the participants. You must join the valedictory session at 3:45 sharp because all the guests, chief guests and all dignitaries were there on the dais at 3:55. So we will be there at the right time. The valedictory session will be going on from 4 to 5 p.m. today. So please join the session by the timings. Thank you so much, all of you.
Thank you.
Thank you, Kostya.
Thank you. Thank you, Mahesh. Thank you, all of you. Hope to meet sometime.
Yeah.
To meet you sometime face to face.
Yeah, we'll meet and we'll
look forward.
Yes.
Okay. Thank you very much. Honored.
Shivraj sir.
Thank you to all of you.
Yeah, thank you, sir. Shivraj sir, please end the session.